Dr. Srinivas. Today's the session is totally for the beginners, okay, and also for the engineering students. Those it is a basic course. I am pointing on the basic course, pointing to their syllabus actually, and here is the topic name is electronic devices and circuits. Okay, our discussion topic is comparison of bipolar junction transistor, junction field effect transistor, and metal oxide semiconductor field effect transistor. Once again, I am telling the topic name: the comparison of bipolar junction transistor, field effect transistor, and metal oxide semiconductor transistor. Okay, so God grace, I have a lot of in-depth knowledge on most of the electronics and communication engineering subjects, and computer science engineering subjects, and also some interdisciplinary subjects such as mechatronics, remote sensing, geographic information systems, okay, so etc. So I have a lot of interest to gain more in depth on the technologies actually, okay, maybe the courses are and also pointing to the advanced technologies such as artificial intelligence, okay, and also for the cloud computing, and also for the artificial intelligence chatbots, like that, etc. So many advanced technologies also I am referring. That's why in this session I will point out so mostly the way, the sequence of the we have to learn the subject, how to learn the subjects. The sequence I will give more importance, of course, in my journey of the as a best researcher, as a the best scientist, and with so many technical awards. I have a lot of interest as on the courses also. Most of the I have a lot of interest on the courses also. Okay, so advanced courses also, of course. Okay, now in this session I will start first with this is an electronics and devices and circuits topic. Okay, we are just comparison of what? Three semiconductor devices. Three are semiconductor devices basically. Three are semiconductor devices, and we are comparing these three semiconductor devices here. Okay, so parameters, take some parameters, and we have to compare the three semiconductor devices. So what are the three semiconductor devices? I am telling. The first semiconductor device is bipolar junction transistor, the other semiconductor device is junction field effect transistor, and the other semiconductor device is metal oxide semiconductor field effect transistor. Once again I am telling those names. I am comparing few parameters of three semiconductor devices. They are three are transistors, of course. Three are transistors, three are semiconductor devices. So those three are bipolar junction transistor, junction field effect transistor, metal oxide semiconductor field effect transistor. Okay, in short, bipolar junction transistor is called as BJT, and in short, junction field effect transistor is called as JFET, and in short, metal oxide semiconductor field effect transistor is called as MOSFET. Okay, so you are in a position to, after this session, you add some more parameters for this. You are in a position to add some more parameters for this tablet form. Okay, like that. That is the efforts what I am expecting from all of you. Okay, the first parameter I am taking the definition. Bipolar junction transistor is basically a bipolar junction device. Bipolar junction transistor is a bipolar junction device. It uses both electrons and holes for conduction. Once again I am telling the definition part of bipolar junction transistor, that is bipolar junction transistor is a bipolar junction device. It uses both electrons and holes for conduction, and this junction field effect transistor is a unipolar junction device. It is a unipolar junction device. Once again I am telling junction field effect transistor is a unipolar junction device. Current is due to one charge carriers, that is electrons or holes, that is either electrons or holes. Once again I am telling junction field effect transistor is a unipolar junction device. Junction field effect transistor is a unipolar junction device. In the current is due to the only one charge carriers. Only one charge carriers, that is either electrons or holes. So coming to metal oxide semiconductor device, it is also unipolar device. It is also unipolar device. But here the highlight point is current is due to one charge carrier, depending on the type of the metal oxide. That means the major difference between junction field effect transistor and metal oxide semiconductor transistor. The major difference is only one layer is different. Okay, in metal oxide semiconductor transistor, one layer is added, but in junction field effect transistor, there is no such type of layers. Okay, some sort of layer will be there that we should observe in the construction part, of course. That is the procedure, of course. Okay, we should observe in the construction part. One layer, additional layer is there. That's why the reason, once again I am repeating that point, that metal oxide semiconductor field effect transistor is a unipolar device, because the current is due to one charge carriers. That is depending on the type of the metal oxide. This is the first parameter we have to evaluate. The next parameter is type of device. Bipolar junction transistor is a current control device. Okay, so and junction field effect transistor is voltage control device. Okay, this is a voltage controller. Again, metal oxide semiconductor field effect transistor is also voltage control device. Metal oxide field effect transistor is also voltage control device. So observe the terminals. Next parameter is terminals. The terminals of bipolar junction transistor, the emitter, base and collector. The terminals of the bipolar junction transistor, emitter, base and collector. And the terminals of the junction field effect transistor, gate, drain and source. The terminals of the metal oxide field effect transistor, again gate, drain and source. Okay, so there are metal oxide field effect transistor also consists of gate, drain and source, no doubt on that. But pinpointedly, practically, one additional thing is there for the metal oxide field effect transistor, that is called a substrate. That you can call it as metal oxide. Or you can call technically that is an SiO2 layer, silicon dioxide layer, like that. That we will see in the construction part, of course. That means the terminals of the junction, generally in the so many sources are writing the metal oxide semiconductors terminals also 3, but coming into practicality, the 4th terminals is also considered. That is called metal oxide terminal. That's what I want to tell you. That is quick called as substrate. Okay. Bipolar junction transistor. Coming to practically pinpointedly, metal oxide field effect transistor has 4 terminals. So bipolar junction transistor terminals are emitter, base and collector, and junction field effect transistor terminals are gate, drain and source. And metal oxide field effect transistor terminals are gate, drain, source, and the other terminal is called it as metal oxide, that you can call it as substrate. Okay, so the next one is applications part. So bipolar junction transistor is used for the low current applications. Bipolar junction transistor used for the low current applications. Junction field effect transistor for the low voltage applications. It is for the low voltage applications. Coming to metal oxide semiconductor transistor, since its power consumption is less, that's why the reason it is used in CMOS circuits. CMOS circuits has a lot of use in the practicality purpose. The word C capital, M capital, O capital, S capital, CMOS. The CMOS abbreviation is complementary metal oxide semiconductor transistors, they are called it as. They have a lot of use CMOS. Actually, you can observe CMOS batteries in your laptop actually. Okay, you can observe that. Okay, in the 5-way part. You will use it the 5-way part. So that CMOS batteries are useful in the laptops actually. Okay, so that is the applications. Okay, then coming to thermal runaway, the next parameter, thermal runaway. Thermal runaway is occurs at only at bipolar junction transistor at a high temperature. Thermal runaway word means it concerns with the temperature at high temperatures. Okay, at high temperatures, what happened to the device? The effect of thermal runaway is there at for the bipolar junction transistor. But when you observe the field effect transistor, there is no thermal runaway. When you observe the metal oxide field effect transistor, there is no thermal runaway effect. Okay, this is the way to learn the device. I am giving the way actually. Okay, so how to learn the semiconductor devices in the comparison manner. Okay, so once the semiconductor, one of the semiconductor device that is the category of transistors, that is bipolar junction transistor. If you have a grip on the construction details, working and symbols and principles, and you automatically you can able to analyze the comparative manner the junction field effect transistor and metal oxide field effect transistors. You can able to easily analyze. Okay, on that way you have to proceed the subject. Okay, to get the more score as well as to get a good knowledge. That's why I am giving this sort of line. Try to update this table with some more parameters. After studying these parameters, okay, you are in a position to give an importance for the logical things. What are the logical things means? So the first logical things here after the some rich source of references I am tabulating, as well as I am giving some beautiful points to you. Likewise, you can refer so many things sources actually. Okay, so and the first thing I want to give here is so why transistor is called current control device. The question number 1 is, you try to answer these questions. Solutions I will tell in the next presentation. Okay, clearly. So why transistor is called as, the question I am telling, current control device. Why transistor is called, the question number 1 is, why transistor is called as current control device. Why the transistor is called as current control device. You should able to answer this question. Why it is called current control device. Okay, and the next question is, what is the significance of arrow head in the transistor symbol? You can easily interpret it, these questions, but you have to gain this type of knowledge. Arrow head in the transistor symbol. Okay, what is its significance? Okay, the next one is you are in a position to interpret so about emitter injection efficiency. Okay, emitter injection efficiency, and also base transport factor, and also how they influence the transistor operation. The question is emitter injection efficiency. These are all related to bipolar junction transistor. Likewise, you can try to answer few questions. I will tell in the next presentation. You try to answer the few questions. I will give so many knowledge based questions based on the junction field effect transistor as well as metal oxide field effect transistor also. Now I am giving the questions pointing to the bipolar junction transistor. Okay, emitter injection efficiency. The next one is base transport factor. Base transport factor. Okay, emitter injection efficiency, base transport factor. What is its how these parameters will influence the transistor operation? How these parameters will influence the transistor operation? The question is very clear. How these parameters will influence the transistor operation? That is the thing. Okay. So how they influence the transistor operation? The next question. The next question we are going to that. Okay. So which of the transistor currents is always largest? Which current is smallest? And which two currents are relatively close in magnitude? Which current is large and which current is small, and which current is so relatively medium current, which is the moderate current, like that. Okay, by observing the structure and working principle, you can easily answer these questions. Of course, you can easily answer these questions. Okay, so you can easily answer these questions. Okay, the next one is why silicon type transistors are more used than germanium type transistors? Why the silicon type of transistors, silicon material based transistors are more useful than the germanium type transistors? Okay, by seeing the formulas. Okay, so by seeing my reference sources, okay, we can easily interpret these answers actually. Okay, try to analyze and in our own. Actually, I am giving for pointing to bipolar junction transistor. Okay, I will give few knowledgeable questions based on junction field effect transistor and metal oxide field effect transistor also. If you analyze these questions, you can get more satisfaction. You can easily score. Okay, and you can get a more grip on the subject, of course. Okay, the next one is the next we are going to that. So the can a transistor is obtained by connecting two semiconductor diodes back to back. Okay, if you connect a diodes like this, the question is very clear. The next question is when two diodes connected back to back. Okay, when two diodes connect to the junction diodes connected back to back. Okay, the question meaning I am telling well logically is transistor is obtained. Is the transistor is obtained? A transistor function is obtained. A transistor function is obtained. It is very important question. That's what I am telling. The knowledge start from the diodes. Diode is also a semiconductor device. Okay, a sequenceable knowledge is required to do more interpretation and analysis on the semiconductor devices. It's a sequence, of course. Okay, so why if you connect two PN junction diodes back to back, okay, a transistor function will come or not. Okay, a transistor function will come or not. That is the my question actually. Try to interpret this logic. I given this question logically. Likewise, you can write the what I am giving some questions. You first write those questions in a clear manner and try to analyze those points in some questions in graphically, some questions with the help of constructional diagram, some questions with the help of formulas, some questions with the help of the working diagram. Like that, you should go in a logical manner interpretation. The next question we will go. This question is very important. Okay. Now the range of the alpha. Alpha is the amplification factor, current amplification factor pointing to the CB transistor. The alpha is always less than negative. The common if you take common emitter amplifier, the current amplification factor is called as beta. The range is starts from here is the range is generally beta value is about it is 200. It's about 200. Its range is generally some about 200. Okay, you can interpret those they are standard values. Of course, they are standard values. Like if you go to the common emitter amplifier, the gamma is nothing but 1 plus beta. The beta, if you know the range of beta standards, easily you can interpret the gamma also, CC amplifier also. Okay, likewise you should know the ranges of those values. That is most important. Okay, next very important one is you should know about ICEO leakage current standard. ICPO. The question is now the technical interpretation regarding to ICEO and ICBO. ICEO and the next question is why CE configuration is most commonly used amplifier when compared to common base and common collector. Okay, why it is most commonly used one. Okay, so the next one is you should know about explain how BJT can be used as amplifier. Explain how the bipolar junction transistor can be used as amplifier. As an amplifier. Okay, I given so many logical interpretation with the standards. Okay, so you analyze these points, interpret these points to enhance more and more knowledge. That is my expectation from all of you. Okay, thank you all. I want to stop at this point. Thank you.